Greetings everyone. I've been doing some feed point measurements and I'd like to show you how I do it. The results I got and everything is relative measurements, of course. We're not trying to measure gain in dB, but we're trying to adjust and tweak and peak the performance of our feed point. So proper alignment for the dish. So here's the technique I'm using. I have my portable 10 gig system, the one I developed in the previous series of video. It's on and in receive. It's receiving 10368.110, so 10 gigahertz. It's sending the IF down, so 144 megahertz through the coax cable, and the coax is connected to the RTL SDR receiver that I have here. That's the easiest way to make measurements, and I'm measuring, of course, at 144 megahertz, 144 and 110, which is the peak right there near the scale. I brought it to the left so I can look at the scale, and like I said, everything is relative. So I told you that the dish at the other end is in receive, and I'm feeding my signal generator a pretty low signal here right into this horn. So I'm sending out to the dish at the other end and watching the receive signal. So that's the easiest way, using RTL SDR, looking at the IF signal. And you'll notice that when I move the azimuth, so the orientation of the antenna, just slightly a little bit like this, not a lot, you can see the signal vary big time on the receiver here. Okay, so that's really the best way, first of all, to tweak our azimuth towards the other antenna, and then we can play with the feed point, move it in and out, move it up, down, tilt it up, down, here, rotate the feed, and that's how you find the sweet spot for the horn or the antenna you're trying to measure. Now there's always the string method that you can use, but what you notice is the measurements I had made, this should be the focus. It comes in below the horn, and the red mark is more like what it is right now. Okay, so it's slightly higher than what the strings gave me, but you can question the measurements I had made on the dish itself to derive the string lengths, you know, from the bottom and the top. But this is, I'd say it's a first position to start with, but then you tweak. And this is what I have here. I've tweaked the thing up and down. Like I said, it also gives you an idea if you tilt left and right and you look at the signal, how much of an impact it has. So does it under illuminate or over illuminate the dish? See, I'm moving a little bit, rotating the feed left and right, and there's a little bit of a movement, maybe half of a dB. Another way to check whether you're over illuminating or under illuminating is to put your hand right here on the edge and see the impact that it has on the signal. And then you see, okay, so it slides a little bit when I move in my hand, so it's probably not over illuminating too much, because when I bring my hand away from the dish there's no movement, but if I bring it in just on the edge, it starts to decrease the signal. So I think that horn is really tweaked for my dish. And just for fun, I've compared my horn to two other antennas. First of all, my reference antenna, which is a pre-made horn, and I get 2.5 dB less of indication on the RTL SDR. So we can say 2.5 dB less of gain with this horn. And the reason is, of course, that this is not optimized for my dish. And I've also tried this modified DSS feed, which we discussed earlier, and it gives about 1 dB less gain, 1 dB less than my horn again. So I will adopt my horn for the final system, I'm pretty sure. I'm gonna have to redo the bracket. The bracket was done for a previous 2.4 gig feed point, so I've marked the position and I can make measurements of the exact horn position, and I'll try to give myself a bit of play you know, some slots to bring in and out the adjustments to optimize everything to the max. And it also allows us, when we look at RTL SDR, it allows us also to check whether moving up or down, so just slightly up or down the system, the kind of impact that it has on the signal. And as you can see, it does have some impact when I move a couple of degrees up and down. See, I'm not quite optimized right now versus the dish at the other end, so it's not totally parallel one into the other, because I have to dip it down a little bit, maybe 1 or 2 degrees, to get the maximum signal like this. If I release it and let it go, it comes down by what, 0.5 of a dB maybe, something like that. So a lot of fun with the RTL SDR, watching the 10 gigahertz signal. Of course, I already have another 10 gigahertz system that allows me to measure at 10 gigahertz. That helps a lot. I'll keep on moving a little bit my feed point just to make sure I'm in the right location, but I'm pretty sure I am. When I'm done with it, I'll just measure everything, the angles and the distances, and replicate something, like I said, with a nicer bracket. And of course, I'll have to weatherize this thing. This is not a setup for outdoors. It's really meant to be indoors at this point. So I'll have to think of a radome or something to protect the whole thing. Alright, all for now. Talk to you soon in the next installment. 7-3.